Hi guys, this is Manohar and welcome to Tutoralz. Today in this video, we are going to discuss about the topic persons adding and leaving in the time and work. Actually, this is the fifth part of time and work tutorial. If you haven't watched the previous parts, I recommend you to please watch the previous parts of the time and work tutorial so that you can come to know what is the concept of time and work and also what are the methods we use to solve the problems. Now in this video, we are going to discuss about the topic persons adding and leaving in the time and work. In this topic, the questions will be like, suppose assume some persons are working together to complete a work. After working for some days, 2 or 3 persons leave the work. Now, the remaining work will be completed by adding 2 or more persons. Okay, the questions will be like this. So, first of all, I will explain the concept behind this and also then we can move to the problems. Okay, now I am assuming the total amount of work done in the time and work will be always one part, right? I have already told you in time and work we will assume the total amount of work to be done will be always 1. Okay. Now and also I am considering one example here. Suppose assume A takes 10 days to complete the work. Okay. Suppose assume the example A takes 10 days to complete the work. Now A's efficiency or A's 1 day's work will be 1 by 10. Okay. A takes 10 days to complete the work. Now A's efficiency or A's 1 day's work will be 1 by 10. Now suppose assume A is working for 5 days. Okay. To complete this one part of work, A worked for 5 days and then A left the work. Now what is the amount of work that is left over? We need to find out. Okay. Suppose assume A is working for 5 days to complete the work. Then after working for 5 days, A left the work. Then what is the amount of work that is left over? We can find it, right? Suppose A is working for 5 days. Okay. Per day A is doing 1 by 10th of the work. Now after working for 5 days, A will complete almost 5 ones, 5 twos, that is 1 by 2 of the work. Okay. After working for 5 days, out of this one part, A has completed 1 by 2 of the work. Now what is the amount of work that is left over? 1 minus 1 by 2. Equal to 1 by 2 part of the work is left over after working for 5 days. Okay. In the same way, they will ask us problems, 2 or more persons will be adding to complete the work and also 2 or more persons will be leaving and what is the amount of work left over. In this kind of problems, the only 2 things we need to remember. One is you need to read the problems very carefully whether it is given total efficiency of a person or total amount of work to be done. Okay, the one thing is you need to read the problems very carefully that whether it is given efficiency or total amount of work to be done. And also the other thing you need to remember is always in this kind of problems you need to find what is the total amount of work that is to be done. Okay, suppose assume if I find what is the total amount of work to be done. Suppose let us assume 100 units of work. Okay, suppose assume 100 units of work to be done is the total amount of work. Then if I find out what is the total amount of work to be done, then I can find out what is the amount of work that is left over. Okay. Suppose assume this is the total amount of work to be done. Then if I find out what is the amount of work that is completed, then I can find out what is the amount of work that is left over. Okay. Now try to remember the basic definition, that is total work equal to efficiency of a person into total time taken to complete the work. This is the basic definition I am trying to tell you from the first tutorial itself, because with this definition only we can find efficiency of a person or total time of a person and also total amount of work to be done. Okay, suppose assume this is the total amount of work to be done. Okay, if I find out what is the total amount of work that is completed, then I can find out what is the amount of work that is left over. Suppose assume 20 units of work is completed. Okay, out of 100 units, 20 units of work is completed by a person. Then what is the amount of work that is left over? 100 minus 20, that is 80 units of work will be left over. And then 80 units of work will be completed by 2 or more persons. Okay, actually this is the concept behind this adding and leaving topic in the time and work. Okay, first of all you need to consider whether it is given efficiency or total amount of work done. And another thing is the total amount of work done equal to efficiency into total time. If you are able to find out what is the total amount of work to be done, then you can also find out what is the work that is completed and also what is the work that is left over to complete the work. Okay, actually this is the basic concept behind this adding and leaving. Now let us look at some basic level problems based on this adding and leaving concept, so that we can come to know how to use this concept in solving the problems. Okay. Now let's see the first problem. They are saying that A and B can do a job in 6 days and 12 days. They began the work together, but A leaves after 3 days. Now the total number of days needed to complete the work. So we need to find out what is the total number of days needed for completion of the work. So they are saying that A can complete the work in 6 days and B can complete the work in 12 days. Now A's efficiency or A's 1 day's work will be 1 by 6 and B's efficiency or B's 1 day's work will be 1 by 12. Now they are saying that A and B started working together and after 3 days A left the work. Okay, after 3 days A left the work. In the sense A have worked with B up to 3 days. Okay, after 3 days A left the work, but up to 3 days A have worked together with B. Okay, now we can write it as A and B. First we need to find out what is the A and B's efficiency or A and B's 1 day's work. Okay, 1 by 6 plus 1 by 12, that is the LCM will be 12 and 1 by 6 into 12, 2 plus 1 by 12 into 12, 1 equal to 3 by 12, that is 1 by 4. This is the 1 day's work of A plus B. So they are saying that A and B together have worked for 3 days. Now A and B have worked for 3 days, in the sense 1 by 4 into 3, that is they have completed 3 by 4 parts of the work. Okay, understand this. A and B have started work together and after 3 days A left the work. So up to 3 days A and B both have worked together. Okay, so A and B's 1 day's work is 1 by 4. They have worked for 3 days. So 1 by 4 into 3, that is 3 by 4 parts of the work is already completed by A and B working together. Now in one part of the work, 3 by 4 part of the work is already completed. So what is the work that is left over? 1 minus 3 by 4. So 1 by 4 part of the work is left over. So to complete this 1 by 4 part of the work, how many days taken by B? So B's 1 day's work is 1 by 12. So we don't know what is the time taken for B to complete the work. Okay, so I am considering it as X. So to complete 1 by 4 part of the work. B's 1 day's work is 1 by 12. We don't know how many days taken by B to complete the work to complete this 1 by 4 part of the work. So if I cancel this, 4 ones, 4 threes, then X equal to 3. So B is taken extra 3 days to complete the work after left by A. So totally they are taking A plus B is working for 3 days and after leaving A, B have worked for 3 days. Totally they are taking 3 plus 3, that is 6 days to complete the work. Okay, understand this. A and B have worked for 3 days and then B alone take 3 days to complete the remaining work after leaving by A. Now they are totally taking 3 plus 3, that is 6 days to complete the work. Now let's see how to solve the same problem in LCM method. Actually in LCM or units method, we can solve these kind of problems very quickly when compared to the normal method. Okay, now let's see how LCM method or units method works. So they are saying that A can complete the work in 6 days and B can complete the work in 12 days. Okay, days, units. Now the LCM of 6 and 12 is 12 units. So the total amount of work to be done is 12 units of work. Now A is completing 12 units in 6 days. So per day A is doing 2 units of work. Per day B is doing 12 by 12, that is 1 unit of work. Okay. Now they are saying that A and B started work together and after 3 days A left the work. Now up to 3 days A and B have working together. So per day A is completing 2 units and per day B is completing 1 unit. So A plus B can do 3 units of work per day. Okay, per day A plus B working together can complete 3 units of work. Now they are saying that A plus B have worked for 3 days. Now A plus B is doing 3 units of work per day and they have working together for 3 days. So they are completing 3 into 3, that is 9 units of work. Okay, they are totally completing 9 units of work by working together for 3 days. So out of 12 units of work, 9 units of work is already completed. Now what is the work that is left over? 12 minus 9, that is 3 units of work that is left over. Now the remaining work need to be completed by B alone. What is the efficiency of B, or what is the work done by B in a single day? That is 1 unit. So to complete this 3 unit, B is taking 3 by 1, that is 3 days. Okay, now A and B have worked for 3 days and B alone worked for 3 days. So they totally take 6 days to complete the work. Okay, so in LCM method, the benefit is we will come to know what is the total amount of work to be done in faster way, and also we will come to know what is the amount of work that is already completed and also left over. Okay, that's the reason we can solve this same kind of problems in LCM or units method very faster way. Now let's see the second problem. They are saying that there is sufficient food for 400 men for 31 days. After 28 days, 280 men leave the place. For how many days the rest of the food lasts for the rest of the men? So we need to find out what is the amount of food that is left over, and also what is the total time taken for the food to be completed by the rest of the men. Okay, so they are saying that there is sufficient food for 400 men for 31 days. Okay, there is sufficient food for 400 men for 31 days. So 400 men can complete all the food in 31 days. Okay, there is sufficient food for 400 men for 31 days. In the sense, 400 men can complete all the food in 31 days, right? So we don't know what is the total amount of work to be done, that is food actually. We have total number of persons here and also total time taken by them to complete the work, but we don't know what is the total amount of work. So to find out total work, we can multiply total number of persons into total time taken by them. So we can come to know what is the total amount of work to be done, that is food here. Okay, 400 men can complete the total food in 31 days. Okay, now 400 into 31 will be, 31 into 4 will be 124, 124,000. This is the 12,400 units or parts. Okay, this is the total amount of work to be done by 400 men. Okay, this is the total amount of work done by 400 men in 31 days. Now they are saying that after 28 days, 280 men have left the place. Okay, so up to 28 days, 400 men are eating the food. Okay, are having the food. Now up to 28 days, some of the food will be completed. So we need to find out what is the food that is completed by 400 men in 28 days. Now 400 into 28 equal to, we will get 28 into 4, that is 56 into 2 and 112,000. So this is the units or parts that is completed by 400 men in 28 days. Okay, up to 28 days 400 men are having the food. So for 28 days 11,200 units are already completed. So in 12,400, 11,200 units are already completed. So what is the work that is left over? 0, 0 and 2, 1. Okay, 1200 units are left over after 28 days food having by 400 men. Now they are saying after 28 days 280 men are left over. Sorry, 280 men are left the place. So out of 400, 280 men are left the place. So what is the men left over? That is 120 men are left over in the place. So for this 120 men to complete this 1200 units of work, totally takes 1200 units by 120 men, that is 10 days. So the food that is left over will last for the left men for 10 days. Okay, I will explain you the problem once again. See, they are saying that there is a sufficient food for 400 men for 31 days. Okay, in the sense 400 men can complete the all food in 31 days. Okay, so we have total men here and also total time taken by them here. So from this we can find out what is the total amount of work to be done. So the total amount of work to be done, that is food, is 12,400 units. Okay, up to try to be clear up to this point. So after this they are saying that up to 28 days 400 men are having the food. After 28 days 280 men left the place. Okay, after 28 days 400 men are having the food. So up to 28 days they have completed 11,200 units. Okay, now after 28 days 280 men are left the place. Now what is the men left over? That is 120 men. Okay, now to complete this 1200 units of food, 120 men takes 10 days to complete the food. Okay, now let's look at our third problem. They are saying that A and B can do a piece of work in 20 days, B and C can do the same work in 24 days. A worked for 4 days, B works for 8 days, C completed the remaining work in 23 days. In how many days A alone can do the work? So we need to find out what is the time taken for A alone to complete the whole work. Okay, now they are saying that A and B can complete the work in 20 days. Okay, and also B and C can complete the work in 24 days. Okay, now the LCM of 20 and 24 is 24 5 120 and it is divisible by 20, that is 120 units. Okay, this is the total amount of work to be done. Now A plus B is completing 120 units of work in 20 days. So per day they are doing 120 by 20, that is 6 units. Per day they are doing 6 units of work. Now B plus C is completing in 24 days. So 120 by 24, that is 5 units of work per day. Okay, now they are saying that A works for 4 days. That is A works for 4 days plus B works for 8 days. B works for 8 days and C works for 23 days. C works for 23 days to complete the whole work, that is 120 units of work. Okay, they are saying A works for 4 days, B works for 8 days and C works for 23 days to complete this 120 units of work. But we don't know what is the efficiencies of A, B and C. So how can we write this A, B and C? We can write in the form of A plus B and B plus C. Then we can substitute these values here. Okay, see they are saying that A works for 4 days, B works for 8 days, C works for 23 days to complete the work. But we don't know what are the efficiencies of A, B and C to substitute the values here. So we can write this same equation as A plus B and B plus C so that we can substitute these values here. Okay, now I am writing this so you can understand. So we can write there are 4 days of A and also 8 days of B. So we can write it as 4 of A plus B, or I will write stepwise so that you can understand. Okay, now they are saying that 4A plus 4B plus 4B. I am writing this 8B as 4B plus 4B, and also I am writing this 23 as 4C plus 19C. Okay, equal to 120. See here they are saying that A worked for 4 days, B worked for 8 days, C worked for 23 days. So I am writing this 8B as 4B plus 4B. Okay, I am writing this 23C as 4C plus 19C. Okay, so that I can write this same equation as 4 of A plus B plus 4 of B plus C plus 19C equal to 120. Okay, now I can substitute this 6 units and also 5 units in the place of A plus B and B plus C. Now you got my point. See, we don't know what are the efficiencies of A, B and C to substitute the values. That's the reason I wrote this same equation in the form of A plus B and B plus C. Now I can substitute these 6 units and 5 units in the place of A plus B and B plus C. Okay, if I substitute these values, I will get 4 of A plus B is 6 units per day and B plus C is 5 units per day. 4 of 5 units plus 19C equal to 120. So 4 into 6 will be 24 and 4 into 5 will be 20. 24 plus 20, that is 44 units plus 19C equal to 120. So 19C equal to 120 minus 44, that is 76 units. So for C it will become 76 by 19, that is 19 ones, 19 fours. So C completes 4 units of work per day. Okay, B plus C completes 5 units of work per day. C alone can complete 4 units of work per day. So if I substitute the C value here, I will come to know what is the work done by B alone in one day. Okay, B plus C can complete the 5 units per day. Now we came to know that C alone can complete 4 units of work per day. So B plus 4 equal to 5. Now B equal to 5 minus 4, that is 1 unit per day. So B's efficiency is 1 unit per day and C's efficiency is 4 units per day. Now if I substitute this B value in the A plus B, I will come to know what is the efficiency of A or 1 day's work of A. So A plus B can do 6 units of work per day. Now we came to know that B equal to 1 unit. Now A plus 1 unit equal to 6 units. A equal to 6 minus 1, that is 5 units of work. A does 5 units of work per day. So we need to find out what is the total time taken by A alone to complete the job, that is 120 units. So to complete this 120 units, A is doing 5 units per day. To complete this 120 units, 120 by 5, that is 5 ones, 5 twos 10 and 5 4, 24 days. Okay, I will explain you once again. See, first of all they are saying A works for 4 days, B works for 8 days and C works for 23 days to complete the work. But we don't know what are the efficiencies of A, B and C to substitute the values here. That's the reason I am writing this same equation in the form of A plus B and also B plus C. Then we can substitute A plus B's efficiency and also B plus C's efficiency in the equation. Okay, now we came that 4 of A plus B and 4 of B plus C plus 19C. So in the place of A plus B and B plus C I am substituting 6 and 5. Then I came to know 19C equal to 120 and C is completing 4 units per day. Now if I substitute this C equal to 4 units in the B plus C, I will come to know what is the efficiency of B. Okay, now B's efficiency is 1 unit. Now if I substitute this B's efficiency in A plus B, I will come to know what is the A's efficiency, that is A's efficiency equal to 5 units. Now to complete this 120 units, A totally takes 120 by 5, that is 24 days. The same problem can also be solved in normal method also, but I didn't tell you the normal method because there are 3 unknown variables. So using this normal method, it takes very long process and also so much time to complete the problem. Okay, now you can ask me why you are telling that normal method when this LCM or units method is very easy. See, no matter how many shortcut methods or how many simple methods you learn to solve the problems, there will be some situations or some problems you cannot solve the problem unless you know the normal or basic method and also basic concept behind the question. Okay, that's the reason I am suggesting you to please solve the problems using both the methods, because when you go to high level exams or very tough questions, when you come across some tough questions, you can come to know which method will be useful to solve the problem. Okay, that's the reason please solve the problems using both the methods so that you can come to know which method will be helpful in which type of scenarios. Okay, now let's see the fourth problem. They are saying that A and B can do a piece of work in 20 days and 12 days. A started to work alone, then after 4 days B joined the work till the completion of work. How long did the work last? So we need to find out what is the total time taken to complete the work. Okay, they are saying that, and this question can be solved in both normal and also units method. So I have written both methods here. I will solve the problem in both methods so that you can understand how to use these both methods in the scenario. Okay, now they are saying that A can complete the work in 20 days. Okay, and B can complete the work in 12 days. Now A's 1 day's work will be 1 by 20. Now B's 1 day's work will be 1 by 12. So they are saying A started to work alone and after 4 days B have joined the work. So up to 4 days A have completed some part of work. Okay, we don't know what is the part of work completed by A. So let us assume the total amount of work to be done as one part. So A is working for 4 days, right? A is working for 4 days. Then A's 1 day's work will be 1 by 20 and worked for 4 days. 4 ones, 4 5. That is, after working for 4 days, A have completed 1 by 5th part of the work in this one part of work. So after 4 days, B have joined the work. Okay, after 4 days, B have joined the work. Now, what is the amount of work that is left over after working for 4 days? That is 1 minus 1 by 5. 1 minus 1 by 5, that is 4 by 5th part of the work is left over after A working for 4 days. Now, to complete this 4 by 5th part of the work, B have joined the work. Now A and B both are working together, right? A and B are working together to complete this 4 by 5th part of the work. But we don't know how many days they have worked together. So let us assume the total days taken by A plus B to complete this 4 by 5th part of the work is X. Okay. We don't know what is the total time taken by A plus B to complete this 4 by 5th part of the work. So I am assuming the total days as X days. Now I will get A plus B, that is 1 by 20 plus 1 by 12 into x equal to 4 by 5. Okay, now the LCM of 12 and 20 will be 12 3 is 36 and 12 5 60. Yeah, 60 units. Okay, 1 by 20 into 60 will be 3 plus 1 by 12 into 60 will be 5. X equal to 4 by 5. Now if I cancel this 5 ones 5 and 5 twos. Okay, now this will be 8, right? 3 plus 5 equal to 8. So if I cancel this 4 ones and 4 twos 8. Now 2 ones 2 6 12. Now x equal to, if I send this 6 to the right hand side, I will get x equal to 6 days. Okay, so after working for 4 days by A and B both together have taken 6 days to complete the remaining part of the work. So totally 6 plus 4, that is totally A and B taking 10 days to complete the work. Okay, after working for 4 days, 4 by 5th part of the work is left over. So to complete this 4 by 5th part of the work, A and B totally took 6 days to complete the work. So totally 6 plus 4, that is 10 days to complete the work. Now let's see how LCM method works. So they are saying A takes 20 days to complete the work and B takes 12 days to complete the work. Now the LCM of 20 and 12 will be 60 units. Okay, this is days here, units. Okay, now A is completing 60 units in 20 days. So per day A is completing 3 units of work. Okay, per day B is completing 60 by 12, that is 5 units of work. Now A started to work alone and completed some part of work for 4 days. A started to work alone and worked for 4 days. Now after working for 4 days, A have completed 3 units into 4, that is 12 units of work. Okay, out of these 60 units, 12 units of work is already completed by A. Now I will get 60 minus 12, that is 48 units. Okay, after working for 4 days, this is the amount of work that is left over. So this to complete this leftover work, B have joined the work. Now A and B both are working combiningly. So A and B both are working combiningly, but we don't know what is the time taken for them to complete this 48 units of work. Let us assume the amount of time taken will be x. Okay, equal to 48 units. Okay, B have joined the work and we don't know what is the total time taken by them. So I am assuming this x days to complete this 48 units of leftover work. Now A is completing 3 units per day and B is completing 5 units per day. So I will get 8 units per day and completing in x days equal to 48 units. Okay, now if I cancel this 8 ones 8 6, x equal to 6 days. So A and B combiningly taking 6 days to complete the remaining part, and also in the starting A worked for 4 days. So the totally 6 plus 4, that is 10 days to complete the work. Okay, now let's see the fifth problem. They are saying that Abhi can do a work in 25 days. Besu is 50% more efficient than Abhi. They started working together, but after 5 days, Besu left and Chaitra joined Abhi such that remaining work got completed in 5 days. Find the ratio between efficiencies of Chaitra and Besu. So we need to find out what is the ratio of efficiency of Besu and Chaitra. Now they are saying that Abhi can complete the work in 25 days. Okay. Now Abhi's 1 day's work will be 1 by 25. Okay. And also they are saying that Besu is 50% more efficient than Abhi. Okay. Besu is 50% more efficient than Abhi. Then the efficiency of A will become 100 and efficiency of B will become 150. Okay, so Besu is 50% more efficient than Abhi. Then efficiency of Besu will become 150 and efficiency of Abhi will become 100%. Okay, now if I cancel this 52s and 53s, I will get 2:3 is the ratio of efficiencies. Since the ratio of efficiency of A:B is 2:3, the ratio of total time taken will be in the ratio of 3:2. Okay, in the previous tutorial I have told you efficiency and total time will be always inversely proportional. Then since the ratio of efficiency of A and B is in the 2:3, the ratio of total time taken will be in the ratio 3:2. Okay, and also we have already know that A takes 25 days to complete the work. Here we know A's total ratio is 3 parts in the total time taken. then we can say this 3 parts is equal to 25 days. Okay, we know that A takes 25 days to complete the work. Then we also know that A is 3 parts in the total time taken. Then we can simply say 3 parts is equal to 25 days. Now 3 parts is equal to 25 days and 2 parts will be equal to 25 into 2 by 3, that is 50 by 3 days. Okay, see here, A takes 25 days to complete the work. We know that A's ratio is 3 parts in the 3:2, which is total time taken. Then we can simply say 3 parts is equal to 25 days. Okay, and also if 3 parts is equal to 25 days, 2 parts will be 50 by 3. Okay, this is the total time taken by Besu to complete the work. Then Besu's 1 day's work will be 3 by 50. Okay, Besu totally takes 50 by 3 days to complete the work. Then Besu's efficiency or Besu's 1 day's work will be 3 by 50. Okay, now they are saying that Abhi and Besu have started working together and after 5 days Besu left their work. So up to 5 days they started working together. So up to 5 days Abhi and Besu have started working together. Now the efficiency of Abhi is 1 by 25 plus 3 by 50 into 5 days. They started working for 5 days. Now I will get 25 and 50 LCM will be 50 and 1 by 25 into 50 will be 2 plus 3 by 50. 5 ones, 5 times 50 and 2 plus 3 I will get 5, right? Okay, 5 ones, 5 twos. So after working for 5 days, Abhi and Besu have completed 1 by 2 part of the work. So the total work to be done is 1 part, right? So out of 1 part, 1 by 2 part of the work is completed. So the remaining part will be 1 minus 1 by 2, that is 1 by 2 part of the work. Okay, after working for 5 days, they have completed 1 by 2 part of the work. So out of 1 part, 1 by 2 part of the work is completed, then 1 by 2 part of the work is left over. And also they are saying after 5 days, Chaitra have joined Abhi. Okay, after 5 days, Chaitra have joined Abhi and they started working together for 5 days to complete the remaining part of the work. Okay, after 5 days, Chaitra joined Abhi and they worked for 5 days to complete the remaining part of the work, that is 1 by 2 part of the work. Now, we don't know what is the efficiency of Chaitra. So, I am keeping it as it is. Efficiency of Abhi will be 1 by 25 plus C into 5 equal to 1 by 2. So, the LCM of will be 25. Okay, the LCM will be 25 and 1 plus 25C equal to 5 equal to 1 by 2. 5 ones, 5 5s 25 and then 1 plus 25. If I send this 5 to the right hand side, I will get 5 by 2 and if I send this 1 to the right hand side, I will get minus 1. Okay, then I will get 25C equal to 5 by 2 minus 1. Okay, 2 ones 2 and 5 minus 2 by 2 equal to 3 by 2. Okay, 3 by 2. So 25C equal to 3 by 2. Then C equal to 3 by 50. 25 into 2, that is 3 by 50. So C's 1 day's work or Chaitra's 1 day's work is 3 by 50. So Chaitra totally takes 50 by 3 days to complete the work. Okay, now we need to find out what is the ratio of efficiency of Chaitra and also Besu. Okay, Besu and Chaitra. Besu's efficiency, that is 3 by 50. Okay, now Chaitra's efficiency also 3 by 50. So the ratio is 1:1. Okay, Besu and Chaitra's efficiency is 1:1. Okay, even without solving all these calculations, we can simply say the ratio is 1:1 because they are saying that Abhi and Besu have worked for 5 days. Okay, Abhi and Besu have worked for 5 days. So they have completed half part of the work. Then Abhi and Chaitra have worked the same time. Okay, here the time is same in both the cases and also Abhi is constant in both the cases. Okay, in both the cases time is constant and also Abhi is constant. So only change is Besu and Chaitra. So we can simply say the ratio is 1:1. Okay, now let's see the sixth problem. They are saying that Shashi can complete a work in 18 days while Lakshya can complete the same work in 3 by 2 time taken by Shashi. Both of them started working together but Lakshya left the work after 2 days. The remaining work is completed by Shashi along with Amit in 4 days. Find the time taken by Amit alone to complete the work. So, okay, so we need to find out what is the total time taken by Amit alone to complete the whole work. Okay, now they are saying that Shashi can complete the work in 18 days. Okay, this question can be solved both in normal and also units method. So I will solve in both the methods so that you can understand how to use these methods in adding or leaving problems. Okay, Shashi can complete the work in 18 days. Lakshya can complete the work in 3/2 of time taken by Shashi, that is 18 days. Okay, time taken by Shashi is 18 days. Lakshya is 3/2 time taken by Shashi, that is 18 days. So we will get 2 ones, 2 nines, that is 27 days. Okay, now Shashi's 1 day's work is 1/18 and Lakshya's 1 day's work is 1/27. Okay, now they are saying that after 2 days of working together, Lakshya have left the work. So up to 2 days, Shashi and Lakshya both have worked for together. Now we need to find out what is the part of work that is completed by both Shashi and Lakshya for 2 days. Okay, so they are saying Shashi and Lakshya have completed some part of work by working for 2 days. 2 days. Okay, now the efficiency of Shashi is 1/18 plus Lakshya is 1/27 into 2. So the LCM of 18 and 27, that is 27 2 is 54 and 54 will be divisible by 18. So 54. Okay, 1/18 into 54 will be 3 plus 1/27 into 54 will be 2 into 2. 2 ones, 2 27s, that is 5/27. So this is the work that was completed by Shashi and Lakshya by working for 2 days. Now what is the part of work that is left over? That is 1 minus 5/27. So we will get 27 ones 27 and minus 5, that is 22/27. This is the part of work that is left over after working for 2 days. Now they are saying that Lakshya left the work and also then Amit have joined the work to complete the work. Okay, Lakshya left the work. Now Shashi joined with Amit to complete the work in 4 days. Okay, to complete the remaining work, that is 22/27 part of the work in 4 days. So Shashi have joined with Amit and completed the remaining part of the work, that is 22/27 in 4 days. Okay, Lakshya left the work and Amit have joined the Shashi. So they have both worked together for 4 days to complete the remaining part of work, that is 22/27. So Shashi's efficiency or 1 day's work is 1/18 plus, we don't know what is Amit's efficiency, so I am keeping Amit as it is, into 4 equal to 22/27. So I will get the LCM will be 18. So 1 plus 18a by 18 into 4 equal to 22/27. So if I cancel this, I will get 9 2s 18 and 9 3s 27. So 2 1s 2, 2 2s 4 and 2 1s 2 11s 22. So I will get, I will send this 1 to the right hand side. So I will get 18a equal to, I will send this 1 to the right hand side. So I will get 11/3 minus 1. So 3 1s 3, 11 minus 1, 11 minus 3/3, that is 8/3. 18a equal to 8/3. So if I send this 18 to the right hand side, I will get a equal to 8/54. 8/18 3 is 54. So this is the 1 day's work of Amit. Okay, 1 day's work of Amit is 8/54. So Amit totally takes 54/8 days. That also can be written as 2 4s 8, 2 27s 54. That is 27/4. This is the total time taken by Amit to complete the whole work. Now let's see how this LCM method works to solve the problem. See, they are saying that Shashi can complete the work in 18 days. Okay. And Lakshya takes 3/2 time of the Shashi takes. Okay. Days, units. Lakshya takes 3/2 of Shashi's time to complete the work. So 3/2 of 18 will be 27. Okay. So the LCM of 18 and 27 will be 54 and 54 will be divisible by both 18 and 27. So 54 units of work is the total amount of work to be done. Now Shashi is doing this 54 units of work in 18 days. So per day Shashi is completing 54/18, that is 3 units of work. Okay, in the same way, Lakshya is completing 54 by 27, 2 units of work. Okay, now they are saying that Shashi and Lakshya have worked for 2 days. Okay, per day Shashi is completing 3 units, per day Lakshya is completing 2 units. So per day Shashi plus Lakshya can do 5 units of work. Okay, they are saying that both are working together for 2 days. Okay, so that 5 into 2 equal to 10 units of work. Per 2 days, Shashi and Lakshya have completed 10 units of work in this 54 units of work. So the remaining work will be 54 minus 10 equal to 44 units of work. Okay, so now Amit have joined this Shashi after leaving Lakshya. So they have completed this 44 units of work in 4 days. Okay, Lakshya have left the job after 2 days. Now Shashi have joined with Amit and worked for 4 days to complete this 44 units of work. Okay, now Shashi's efficiency is 3 units per day. 3 plus we don't know Amit's efficiency, so I am keeping it as it is, 4 equal to 44 units. Now 4 ones, 4 11s, and if I send this 3 to the right hand side, I will get A equal to 8 units per day. So A is completing 8 units of work per day. To complete this 54 units, A will take 54 by 8, that is 27 by 4 days. Okay, and try to solve more and more problems based on this adding or leaving persons in the time and work. The only thing you need to consider here is, whenever you come across adding or leaving persons in the time and work, you need to consider what is the total amount of work to be done. Then you can find out what is the amount that is completed and also what is the amount of work that is left over. If you are able to write this, then you can solve the problems very easily in the exams. Okay, and that's it for this video. For more tutorials like this, please subscribe to the channel. Thank you.